Should be live. Alive. Okay, just testing my sound and this application as well. I don't have any CEO talking into my ear. It's just sound check. Just trying to say that I'm using the correct microphone. And yeah, this microphone is well, kind of mid-range, whatever, not like semi-professional. So it actually goes up how many, 15 hertz or so? Yeah, a bit higher. This will be cut off at 15 kilohertz, not hertz. And we have a high pass as well. It used to be, the reason I added the high pass is that there was constant noise. Maybe there was something outside that I potentially couldn't even hear, but that's why I added the high pass. And yeah, even with this microphone, still not going up the electrode array. There's meant to be higher frequencies up there. We actually, yeah, so you can see how filtering works essentially. So now I should be activating high frequency electrodes. But it's just the noise. A lot of the other stuff would not be coming through. So you can actually test how good your microphone is if you want. Yeah. So yeah, that was a click, a mouse click. Yeah, and a lot of this noise would not be coming through into the audio stream because the streaming software has its own audio filtering, so it should be filtering those annoying noises that I make or just in the environment. Yeah, you can change the number of electrodes again for you to activate the higher frequency electrodes. Yeah, you either need a better microphone potentially or use the high pass filter and see what it does. I don't know, on a different device it potentially would not work at all because those frequencies will not be coming through into the microphone. Yeah, I'm doing development in a sec. Just want to mention, yeah, someone posted on LinkedIn that apparently if you just pop it back in there. Yeah, so apparently if you ask GPT-4 not for a number between 1 and 100, it will give you a bias response. Yeah, once it's like the number is 42, yeah, obviously the answer for everything. 47, 74, I don't know if those are biased or not. yeah, different numbers. But don't forget, when you asking, like, if assuming what you're asking for is a random number between 1 and 100, and if you use the magic word and ask nicely for a random number, then it's actually using Python to generate the code and generate the result, return the random number. So before you post about how GPT, ChatGPT, whatever, is not good and how it's producing biased results, it's only mimicking humans, and humans produce biased results. Therefore, it's doing what it meant to do, mimicking a person. When in a language, neural language, whatever, large language mode, human language model. Yeah, so don't forget to ask properly what you are after, and certain task should choose the right tool for the task. And if you want a random number, use a mathematical equation, programmatic function like random in Python, and you'll be gold. Let's move on. We'll be developing couple things. Yeah, so first, if you haven't done so already, go check out biomedical.com. Should be biomedical.com, 1C. Should train the bot. You can actually train the bot now. Yeah, in this case, yeah, we'll start in a sec. Bear with me. Yeah, we'll start developing in a second. We have 3 things going on. We have this knowledge graph. A simulation can run at the quickly see if it still works or not. Yeah, so this one will take text. Can have a very long text if you like. Just use something from my website. Yeah, and we'll generate knowledge graphs out of it. Yeah, so this text is not very comprehensive, just a description for this application. Right, so this knowledge graph, if we take a longer text, so it's updating as you type, which is kind of nice. Yes, we do have Black Mirror mention in this blog. Brain gate. Yes, so they still have to fix the way it looks. Yeah, that's obviously the authorship thing that we, so if we remove it, it will get rid of it. Don't know why this is repeated twice. There should be no repeats, and there should be some way. There should be some way of showing all the text in that node here. Let me check. Where is it in the text? We have a sentence starting with one of the key benefits. One of the key benefits. Yeah, but that should not be a node of itself, is it? So yeah, we'll have to improve this one. We also right, we're trying to pass feed data files. So those are your data from health wearables, which we'll try pulling data out of those. Ideally using JavaScript. So front end. Well, several reasons, mainly because I don't want you to be able to upload your data to my server. Because various reasons, privacy, security, so on and so forth. So we also have a feed data that currently doesn't work. I don't know why Visual Studio Code is taking so much resources. And what else we got? What else we got? Right, and we will have a new application. Which probably is the one we start with. It will be called simply gate, and the bot seemed to know a lot about gate. Yeah, I don't know, it's already went into programming mode. It knows I'm doing Flask applications. That's in the memory of the robot. But let's prompt it. Prompt it some more. Actually started off a discussion on LinkedIn. And unfortunately, we have to use the phone for the the text to speech and speech to text function of the ChatGPT app. So we open the same chat that we have here on the screen. Unfortunately, we cannot use the regular conversation thing because it's considered a phone call, which is a bit unusual, but okay. So we'll just have to use the regular microphone function. Okay, so a couple of things. Yes, you are correct. We do want eventually turn everything into a Flask application. That's great. However, we want to focus on a specific thing. So a couple of requirements. First, we do not want an option for the user to upload the data Another condition is that we want to do as much as possible in JavaScript and only use back end Python if absolutely necessary. Now, regards the gate simulation, we would essentially like potentially one option is a 2D model of the foot and the heat map displaying changes of where pressure is, and we essentially want to be able to compare a normal healthy walking to a gate freezing situation. We want the application to be one display, a single display application. And also if you can answer some questions of, what libraries, ideally JavaScript, do we use for visualization? How about the gate data? Can you simulate, would we be able to simulate healthy walking as opposed to different stages of gait freezing, say in Parkinson's? And could we develop or implement an open source model to detect the difference between the two? Also touch on sensitivity and specificity of a model like that. So we converting all this into text. Seem to have done a good job, but we'll see in a second. While it's generating, go check out biomedical.com. There's a lot of interesting tools that at some stage we'll come back to. That's something. Yeah, generated a lot of code. Can you give a quick summary without any code, changing any code or adding any new code, just the text alone? I'll actually remove quick. I didn't get the sentence correctly. Get some water stuck under a rock and between rock and sand in there. Okay, we'll read this one out loud.
To create a gait analysis application that compares normal, healthy walking to gait freezing situations, the approach involves several key steps and tools, focusing on JavaScript for front-end processing and Flask for minimal back-end support if needed. Front-end development with JavaScript. 1. Visualization libraries. D3.js, ideal for creating complex visualizations, such as heat maps to display pressure changes on a 2D foot model. 3.js, useful for 3D visualizations if needed. Chart.js, suitable for basic charts and visualizations. Pixie.js, efficient for animations and interactive graphics. 2. Creating visualizations. Use D3.js to render a 2D model of the foot and overlay heat maps showing pressure points during walking. Simulating gait data. 1. Healthy walking, characterized by smooth, consistent pressure distribution with regular stride lengths and cadence. 2. Gait freezing, exhibits irregular pressure points, sudden changes in stride length, and pauses in movement. Back-end development with Flask 1. Data simulation. Use Flask to generate and serve simulated gait data for healthy walking and gait freezing scenarios. 2. Data serving. The back-end Flask application can serve this data to the front-end JavaScript for visualization. Sensitivity and specificity of gait models. 1. Sensitivity measures the model's ability to correctly identify instances of gait freezing, true positives. 2. Specificity measures the model's ability to correctly identify instances of normal walking, true negatives. Developing an open source model. 1. Data collection. Gather or simulate gait data for different conditions. 2. Feature extraction. Identify key features like stride length, cadence, and pressure distribution. 3. Model training. Train a classification model to differentiate between healthy walking and gait freezing. 4. Evaluation. Assess model performance using metrics like sensitivity and specificity. Conclusion. By leveraging JavaScript for front-end visualization and minimal back-end support with Flask, you can create an interactive gait analysis application. This system will simulate and analyze gait data, comparing healthy walking with gait freezing, and potentially use machine learning models to detect and differentiate between these conditions, ensuring high sensitivity and specificity.
A couple of things. So if you can choose the best visualization JavaScript library, that would be great. Now, can you touch on the difference between simulating gait data and actually potentially can you search for any open source datasets that include the gait data from Parkinson's patients? Again, can we make sure we're doing as little as possible in the backend? I'm trying to save electricity. So primarily rely on JavaScript. Yeah, with sensitivity and specificity of gait models, yeah, if you can look up what's already available in literature, eventually, yes, we would like a couple of examples of normal gait and abnormal gait to be able to simulate in our Flask app gait simulator. Yes, so we don't have an option to gather gait data ourselves, so we'll have to either simulate or use public datasets. If you can list the different features, that will be great. Just a quick list and sorry, just give the whole list with a short description of each feature. It's converting to text pretty quickly. I assume that's correct. It's mostly doing it correctly. Yeah, now it went into searching the web mode. It said it searched for 4 different websites, so on and so forth. It's actually Michael J. Fox, yeah. Parkinson, Physionet. That looks promising. Yeah, it's obviously using Bing. Okay, it should be fine. Did it finish?
Best visualization library for the visualization of gate data, D3.js is the most suitable JavaScript library. It is highly flexible and powerful, allowing you to create interactive, custom visualizations such as 2D heat maps. D3.js works well with SVG and can handle complex data-driven visualizations, which makes it ideal for displaying gate pressure changes and comparing different gate patterns. Difference between simulating gate data and using open source datasets. Simulating gait data, healthy walking. You can create simulated data that mimics regular, consistent pressure points, stride lengths, and cadence. Gait freezing. Simulated data can include irregular pressure points, sudden changes in stride length, and pauses, replicating the freezing episodes seen in Parkinson's patients. Using open source datasets. Real data. Open source datasets provide actual recorded data from Parkinson's patients, which includes the nuances and variability of real-world gait patterns. Accuracy. Using real data can improve the accuracy and reliability of your analysis and models. Open source datasets for Parkinson's gait data. One multimodal dataset of freezing of gait in Parkinson's disease. This dataset includes multimodal data such as EEG, EMG, ECG, skin conductance, and accelerometry, specifically collected to study freezing of gait in Parkinson's patients, 18 source. 2. Gait in Parkinson's disease, PhysioNet. This dataset contains multi-channel recordings from 4 sensors beneath the feet of Parkinson's patients and healthy controls, providing a comprehensive set of gait data for analysis. Features of gait data. 1. Stride length, the distance covered between successive foot contacts of the same foot. 2. Step length, the distance between the initial contact of one foot and the subsequent contact of the opposite foot. 3. Cadence, the number of steps taken per minute. 4. Ground reaction force, the force exerted by the ground on the foot during walking. 5. Pressure distribution, the distribution of pressure across different parts of the foot during gait. 6. Swing phase duration, the duration of the swing phase when the foot is off the ground. 7. Stance phase duration, the duration of the stance phase when the foot is in contact with the ground. 8. Acceleration, the rate of change of velocity of the foot during walking. 9. Electromyography, EMG, measures muscle activity during gait. 10. Electroencephalography, measures brain activity during gait. Sensitivity and specificity of gait models. Sensitivity and specificity are critical metrics in evaluating the performance of gait models. Sensitivity measures the model's ability to correctly identify instances of gait freezing, true positives. High sensitivity ensures that most freezing episodes are detected. Specificity measures the model's ability to correctly identify instances of normal gait, true negatives. High specificity ensures that normal walking patterns are not mistakenly classified as freezing episodes. Literature on gait models. Research has shown that models combining multimodal data, e.g. accelerometry, EEG, EMG, can achieve high sensitivity and specificity in detecting freezing of gait. These models are trained to recognize the distinct patterns associated with gait abnormalities in Parkinson's disease, 18 source, 20 source. Conclusion. To build an effective gait analysis application, focus on using D3.js for visualization, leverage open source datasets for real-world accuracy, and aim to develop models with high sensitivity and specificity. This approach will ensure an efficient and reliable application while minimizing back-end processing.
Yeah, normally we would have more prompts. Yeah, just pop it in there. Okay, so couple of questions. The features looks great. Now we want a functional Flask application that will have a choice between normal and abnormal gate that we could compare side by side. The interface, how about a 2D model of the foot with heat map of where the pressure is, and we should be able to scroll it back and forth to see the difference between normal and abnormal gait. Let's see if it will go back into development mode or create instructions for GitHub Copilot. Ask for a Flask application template. Getting an error. Okay, did the code. Should actually be it should be prompt to a prompt one. The info should include that. Just have gate, probably theme or something. A bash commands to create a project structure. Just generate the whole thing. Make the gate, cd gate, make this static. Yep, templates, data. What is it doing now? Okay, just keep going. Yep. Scripts index, normal gate, abnormal gate. I don't know who is gonna simulate those. Let's try. It's creating the HTML. Is it specific HTML or just generic? Title, header, canvas. A canvas element where we draw the gate data. Edge. It's trying to make it Edge browser compatible. Okay, no, the thing from GPT-4 is much better. What's the get the shortcut? So we're already in the gate, city gate. Just need those. Oop. Where on earth did they go? What just happened? My file browser is playing up. It's not showing the changes made. What? Right, it is now. Just weird. That was weird, but okay. Okay, so we have the file and folder structure. Still not sure what and how are we gonna generate those JSON data files. We have templates, HTML. We're using D3, a JavaScript library, time slider, heat map. Okay. Okay, so we have 43 lines of a JavaScript and a CSS file. Okay, we're using div3.js, data handling, preload, and serve gate data for both normal and abnormal conditions. Um, okay, this will be interesting. How do you suggest we generate the data files? Would we have a 2D model of the foot, and the data files should have data over time of a normal and abnormal walking gait. The values should be pressure within the 2D foot model, and all this should be displayed on two separate canvases on the front panel. Again, primarily, how do we generate, or where do we get the data from? Well, yeah, we have a couple of data sets. What are these text files? Vertical ground reaction force. Okay, and are they right? So they are a Parkinson's disease patient and normal and healthy controls. That sounds. Sorry, I forgot to send to click send. Okay, it's actually well, it's just a data structure, isn't it?
To generate the data files for normal and abnormal walking gaits and display them on two separate canvases in your Flask application, you can follow these steps. Step 1. Data generation, using open source datasets. One multimodal dataset of freezing of gait in Parkinson's disease. This dataset includes multimodal sensor data from Parkinson's patients experiencing freezing of gait. You can use the accelerometer and pressure data to extract relevant features. Repository, multimodal dataset of freezing of gait in Parkinson's disease on GitHub. github.com/multimodal Parkinson data processing, 18 source. 2. PhysioNet gait in Parkinson's disease. This dataset contains force sensor data from the feet of Parkinson's patients and healthy controls, which can be used to simulate pressure distribution on a 2D foot model. Repository, PhysioNet gait in Parkinson's disease, physionet.org/content gait PDB 1.20 source. Simulating data. If you prefer to simulate the data, you can create synthetic datasets based on typical characteristics of normal and abnormal gait. 1. Normal gait, regular, consistent pressure points, smooth transitions between steps, constant stride length and cadence. 2. Abnormal gait, gait freezing, irregular pressure distribution, sudden changes in stride length, periods of no movement freezing episodes. Step 2. Create data files. Create JSON files to store the simulated or extracted gait data. Example data structure. Normal gait.json, JSON time 0, x100, y.
Okay, so first those are still not complete. Okay, it's better than nothing. Let's store that for a sec. So I don't know if it can actually simulate that foot pressure on the 2D model. Also, yeah, we'll have two separate canvases for normal heat map and abnormal heat map. A loading gate data, normal, abnormal. We have updated heat map as well. Styling for the heat map. Okay. Okay, can you just not that will be the same, obviously. Okay, keep repeating itself. Yeah, I'm pretty sure GitHub Copilot won't be able to do this. It keeps going for the steps. What is generating random stuff for? Why is it only 10 pressure points? Okay, we can try and increase it later. How realistic is this simulation? I don't know. Okay, how realistic this gate data generation is? Is it based on the datasets, parameters from the datasets you mentioned earlier, with just random stuff? Also, any chance you can just generate the JSON files completely? Okay, I get the idea. I think we're getting stuck here. So this application won't be doing much. I mean, we can run it. Still have the knowledge graph going. What is it suggesting translation from German for? Okay, what did the two buttons meant to do? Right, it's actually generated stuff. Okay. So it's actually run the code on the server. I need a copy of that. If that's generating like simulated synthetic gate data. Data generate this Python code. Yeah, we need that code for sure. Let's actually run the thing and can download the file. Does that work? Does work. Let me fetch. It only like 100 kilobyte. Replace. Replace. Okay, I don't see it. Why? Any errors? Yes. It's not valid JSON. What? Is the data meant to be in the static folder? I bet. Where's the error coming from? What is it? Recognizing as German. Get it, no errors, but oh, come on. Don't see the data. There are no errors. Pressure points are distributed consistently, reflecting smooth walking patterns typically observed in healthy individuals. In abnormal gait, data pressure points show more variability, especially with some timestamps having 0 or very low pressure values. Okay, simulating freezing of gait episodes common in Parkinson's disease. Yeah, based on general patterns in real datasets. Okay. Data director via Flask previously provide that could serve the visual dance will allow you compare normal blah blah blah. Okay, except it's not showing anything, not giving any errors as well. I think the model is not there, is it? Yeah, now it's the tricky bit of actually troubleshooting this stuff.
To ensure the heat map is correctly overlaid on the foot background image, let's go through the steps and potential issues. Overview of current setup. 1. HTML and CSS. The HTML structure includes divs for normal and abnormal heat maps. CSS sets the background image for these divs and their dimensions. 2. JavaScript fetches gate data and updates the SVG elements within the heat map divs. Coordinates of data points are scaled to fit the background image. Ensuring heat map overlay. 1. Verify SVG overlay. Ensure the SVG elements are correctly appended within the heat map divs. 2. Coordinate scaling. Adjust the coordinates of the data points to fit within the dimensions of the foot background image. Steps to ensure correct overlay. 1. Check SVG element positioning. Make sure the SVG elements are appended inside the heat map divs and are not hidden behind the background image. 2. Adjust data point coordinates. Scale the coordinates of the data points to ensure they align with the foot background image. Updated JavaScript, scripts.js. Ensure that the SVG element is placed correctly within the div and that the coordinates are properly scaled. JavaScript document.addEventListener, DOM content loaded function, const normal b10, document get element by ID normal b10, const abnormal b10 equals document get element by ID abnormal b10, const time slider equals document.get element by ID time slider. Const normal heat map equals d3 select normal heat map append svg dot adder width 500 adder height 500 style position absolute. Const abnormal heat map equals d3 dot select abnormal heat map but append svg dot adder width 500 adder height 500 style position absolute. Let normal gate data equals let normal gate data let max time equals to 0 normal b10 dot add event listener click equals to load gate data normal abnormal b10 dot add event listener click load gate data normal time slider to add event listener input update heat maps. Function load gate data gate type fetch data slash gate type then response.json then dinsel.log loaded dog type data data slash loaded data if gate type equals normal gate data equals data else abnormal gate data equals data max time equals math.max normal gate data length abnormal gate data length by 1 time slider.max equals max time update heat maps dot catch error equal console.error error fetching gate data error function update heat maps const time with time slider.value update heat map normal gate data time update heat map abnormal gate data time function update heat map data heat map.select all.remove if data return data.for each heat map.append circle .atcher cx point x5 I slash adjust x coordinate to fit the background image or cy point y5 adjust y coordinate to fit the background image at r point pressure style fill red style opacity 0.6 load default data load gate data normal load gate data abnormal updated css styles.css ensure the positioning of the svg elements is absolute and within the heat map divs css body font family arial sans serif position relative canvases display flex justify content space between heatmap width 500px height 500px border 1px solid dd background image url for static file name equals images foot background.png background size contain background repeat no repeat position relative input 100% button margin 5px hashtag checking data generation. If the coordinates do not align properly, you may need to regenerate the data to ensure they fit the background image dimensions. The current coordinate scaling, 5, might need adjustments based on the actual size and proportions of the background image. Regenerate data, if necessary. Ensure the generated data fits within the 500 by 500 pixel range, or adjust the scaling factor accordingly. If you still encounter issues, please provide details on the coordinates of the data points or any additional information so that I can assist you further.
With only pseudo code, we need to fix quite a few things. First of all, the image doesn't look like the canvas doesn't look like a heat map. So the heat map only has one color. Normally, heat map obviously will have multiple colors, so we need to fix that. Second, instead of having the background image, is it possible uh, to have the heat map alone, but with the cold images, essentially when there is no pressure being always there. So instead of zero pressure being no color, we would like zero pressure to be blue, and then accordingly, based on standard heat map colors, as the pressure goes higher, the color intensity should increase to, sorry, not intensity, but the color should turn essentially red for high pressure and blue for no pressure. We would like to see both feet, left and right, essentially a simulation of walking. On the left we have normal gait, and on the right we have abnormal gait. Again, the background image of the foot is not necessary if we get the heat map correct, and making sure it's not going to no color. So 0 should be blue and 100% pressure should be red. Whew. It's converting this to text. Let's assume the text is correct and see what it says. It did pretty well so far. So no major hallucination or anything. Yeah, I forgot to mention the buttons are not necessary, and we might want to put a play button instead. Yeah, this one is just generating or regenerating. A 175. No, they're not actually doing anything, so.
Let's break down the necessary changes to implement a heat map visualization that meets your requirements using pseudocode. This will include 1. Generating a heat map with colors ranging from blue, low pressure, to red, high pressure. 2. Simulating both feet, left and right, with normal gait on the left and abnormal gait on the right. 3. Ensuring zero pressure is visualized as blue and increasing pressure changes color progressively to red. Pseudocode overview. Front-end JavaScript D3.js. 1. Set up HTML structure. 2 divs for normal and abnormal gait heat maps. Range slider for time control. 2. CSS. Define styles for the heat map divs. 3. JavaScript. Load and parse the gait data. Generate heat maps with color scales. Update heat maps based on the time slider. Pseudocode implementation. HTML structure. HTML doptang head. Metacharset UTF-8. Title gate analysis style sheet map. The styles.slash d3js.org/d3.6.min. Thascrishi scripts.normal. Normal gait. Normal gait. Abnormal gait. Input type range, ida time slider, min is 0, max 100 value div. Div normal heat map, class abnormal heat map. CSS styles, CSS body, font family Arial, sans serif. Char canvases, display flex, justify content, space between. Heat map, width 500px, height 500px, position relative, input 100%, button, margin 5px. Struct JavaScript logic, D3JS. JavaScript document.addEventListener, DOM content loaded function. Const normal b10 document get element by a normal b10. Const abnormal btn equals document.getElement by ID abnormal btn. Const time sliders document get element by ID time slider. Const normal heat map d3.select hap normal heat map append svg width 500 at or height 500. Const abnormal heat map equals d3.abnormal heat map append at width 500 at or height 500. Let normal gate data equals. Let abnormal gate data equals. Let max time equals 0. Normal btn.add event listener click equals load gate data normal. Abnormal btn.add event listener click load gate data abnormal. Time slider.add event listener input update heat maps. Function load gate data gate type. Fetch data all gate type, then response.json, then data equal console.log loaded doll gate type data, data. Log loaded data if gate type equals normal, normal gate data equals data. Else, abnormal gate data equals data. Max time equals math.max normal gate data.length, abnormal gate data.length, nice one. Time slider.max equals max time. Update heat maps. Catch error, console.error, error fetching gate data, error. Function update heat maps. Const time equals time slider.value. Update heat map, normal gate data time. Update heat map, abnormal gate data time. Function update heat map data. Heat map.select all.remove. If data, return. Define color scale for the heat map. Const color scale equals d3.scale sequential, d3 interpolatable bloom if 10. Data.h heat map.append circle add or cx point.x star 4 adjust x coordinate scaling dot add or cy point.y to 4 adjust y coordinate scaling dot or r point.pressure dot style fill color scale point pressure style opacity 0.6. Load default data, load gate data normal, load gate data abnormal. Ashcar summary of changes. 1. Heat map color scale. Use d3.scale sequential with d3.interpolate blues for blue to red color mapping based on pressure values. 2. Zero pressure as blue. Ensure the color scale starts at blue for zero pressure. 3. Remove background image. No need for a foot background image if the heat map alone suffices. 4. Visualize both feet. Ensure both left and right foot data are visualized for normal and abnormal gait simulations. 5. Coordinate adjustment. Adjust the data point coordinates to fit within the 500 by 500 SVG canvas. By following these steps, you can create a heat map visualization that accurately represents the pressure data for normal and abnormal gait. To generate realistic gait data for both left and right feet, ensuring that the heat maps look like feet and cover a single step cycle, let's regenerate the function. This will include simulating pressure points for the entire foot area over a typical step cycle. The pressure points will be distributed across both feet, and the data will be structured to reflect the progression of a step. Python code to generate gait data. We'll generate data that simulates the pressure distribution during To generate exact foot coordinates that resemble the shape of a foot, we can use a predefined pattern for the pressure points. We'll create a set of coordinates that represent key areas of the foot, such as the toes, ball, arch, and heel. These coordinates will then be used to generate pressure data for both normal and abnormal gaits. Here's a sample approach to generate foot coordinates and simulate pressure data. Python code for generating foot coordinates and gait data. 1. Define foot shape. Predefine a set of coordinates that represent the foot shape. 2. Generate gait data. Simulate pressure variations over these coordinates for normal and abnormal gait. Step 1. Define foot shape. We'll define a set of coordinates that represent key areas of the foot. Python import JSON. Import math. Def generate foot shape. Define coordinates for key areas of the foot. X, Y, foot shape equals X 50, Y 180. Heel center, X 40, Y 160. X 60, Y 160. Heel sides, X 30, 140. X 70. Arch, X 20, X 80, 120. Ball sides, 25, Y 100. Ball center, 30, 80. X 70, Y 80. Midfoot 3560, X 6560. Toes base X 40, Y 40, X 60, Y 40. Toes tips X 50, Y 20. Big toe tip. Return foot shape def generate gait data normal equals true. Data equals num time steps equals 100. Simulate 100 time steps for a single step cycle. Foot shape equals generate foot shape. For t in range num time steps, time data equals time t, left foot, right foot. Simulate pressure points for left foot for point in foot shape. X equals point X, Y equals point Y if normal. Pressure equals 1 t the num time steps, ta2 math.pi 1 ta to 5. Normal gait with sinusoidal pressure variation else. Pressure equals math.pi 1 2.5. Abnormal gait with irregular pressure variation. Time data left foot append X, X, Y, pressure. Simulate pressure points for right foot for point in foot shape. X equals point X, Y equals point Y. If normal, pressure equal math.cos t not my num times steps, ta2 math.5. Normal gait with sinusoidal pressure variation else, pressure equals math.cos t num times steps 4 math.pi 2.5. Abnormal gait with irregular pressure variation. Time data right foot append XX, Y, Y, pressure, pressure. Data append time data. Return data. Generate and save normal gait data. Normal gait data equals generate equal gait data, normal equals true, with open slash mcat data normal gait.json, ww as f, json.dump, normal gait data f indent 4. Generate and save abnormal gait data. Abnormal gait data equals generate gait data, normal equals false, with open mnt data slash abnormal gait.json as f, json.dump, abnormal gait data f indent summary. 1. Foot shape coordinates, a predefined set of coordinates representing the foot shape. 2. Gait data generation, simulating pressure variations over these coordinates for normal and abnormal gait. This approach ensures that the heat map visualization accurately represents the shape of the feet and the pressure distribution during a step cycle. You can then use the generated JSON files in your visualization code as previously described. To generate accurate foot coordinates and ensure the data reflects a single step cycle for both normal and abnormal gaits, we can use the provided dataset and format. Here's how we can proceed. 1. Extract data from dataset. Use the dataset to extract the pressure values for each sensor over time. 2. Transform data to JSON format. Convert the extracted data into the required JSON format for visualization. Pseudocode for data extraction and transformation. 1. Read the data file. Read the data file line by line. Parse each line to extract time and sensor values. Store the data in a structured format. 2. Transform to JSON format. For each time step, create an entry with the sensor positions and pressure values. Ensure the JSON format matches the expected input for the visualization. Here's a detailed step-by-step pseudocode. Pseudo function extract and transform data file path. Define sensor positions based on the format left sensors equals x 9500, y guess 800, x 9700, y 400, x3 y y 0, x 9300, x 9700, y 400, y 400, x 9500, y 800. Right sensors equals 500, y is 800, x 700y, 9 is 400, x 300, y 9 is 400, x 700, y 000, y 0, x 700, y 400, x 500, y 800. Data equals. Read the file with open file path R as file. Lines equals file.readlines. For line in lines, columns equals line.strip, split. Time equals float, columns 0. Left forces equals float F for F in columns 1, 9. Right forces equals float F for F in columns 9, 1. Left data equals right data equals. For I in range 8, left data.append pressure, left forces I, X, left sensors X, Y. Right data.append pressure, right forces X, right sensor Y, right sensors IY. Data.append time, left foot, left data, right data. Return data. Sure. Example usage. Normal gate data equals extract and transform data / path to gecko11.lextion. Abnormal gate data equals extract and transform data / path / abnormal gate data.txt. Convert to JSON and save import JSON with open normal gate JSON W as F. JSON.dump normal gate data F with open abnormal gate.json W as F JSON dump abnormal gate data F. Steps to ensure proper visualization. 1. Read the JSON files in JavaScript. Load the JSON data for both normal and abnormal gates in your JavaScript code. 2. Generate heat map. Use the d3.js library to generate a heat map based on the sensor data. Map the pressure values to a color scale, e.g. blue for low pressure to red for high pressure. 3. Overlay the heat map on the canvas. Draw the heat map points on the canvas. Ensure the heat map points align with the foot coordinates. Visualization improvements. Adjust the color scale to ensure blue represents 0 pressure and red represents maximum pressure. Make sure the foot coordinates in the dataset correctly represent the shape and layout of the foot. By following these steps, you will ensure that the heat map accurately reflects the foot's pressure distribution and provides a clear comparison between normal and abnormal gaits. To complete the table of coordinates for a pressure sensing insole with precise data, here are some specific insights based on manufacturer's specifications. 1. Modicon Open Go sensor insoles. These insoles have an array of 13 capacitive pressure sensing pads and a 3D accelerometer for motion measurement. They use Bluetooth Low Energy for data transmission and offer different operation modes, including live data streaming and recording mode for independent use 25 source, 27 source. The insole is available in 9 different sizes and offers 2 top layer materials for comfort and durability. Number 2. X-Sensor Intelligent Insoles Pro. This system provides high-resolution data with up to 235 sensing points per foot, capable of capturing plantar pressure and gait metrics with high accuracy. It operates at a high speed of up to 150 Hz and has robust onboard memory for autonomous data collection 26 source, 28 source. The sensors are designed for continuous use and high durability, ensuring reliable data collection over thousands of cycles. 3. MAR Systems. Their insole includes 13 pressure sensors and an integrated 3D accelerometer, processing data through an embedded microsystem. This design ensures usability and precise measurement of pressure distribution, weight, balance, and motion in real time, 27i source. Based on this information, you can refer to these specific product details to find the exact sensor coordinates for each insole model. Manufacturers typically provide detailed layouts and calibration data in their technical specifications or upon request. For exact coordinates and further customization, contacting the manufacturer directly or consulting their detailed technical documentation would be necessary.
Okay, that was painful. So couldn't find the coordinates for the foot. So probably, I don't know, could draw them myself or something, but the bot couldn't get it, and there's no good source. Um, so currently, this is what we have. This is meant to be generally what it is. It's an attempt to compare normal on the left and abnormal on the right gait. This meant to be one step cycle. This meant to look like a foot. Yeah, maybe kind of foot of a chicken. And while the buttons are not needed, maybe a play loop button instead. And this meant to show you the difference between pressure to the foot model. But yeah, as you can tell, needs more work. Close it for now. Pop all the chat into a knowledge graph. Oh, right. Yeah, it's a giant one. Okay, there's a lot of rubbish. Well, because that's all the code. Just asks for a text summary, but yeah. Yeah, you don't want to put code in there. They look like viruses. And the sample thing could be made longer. Yeah, you kind of can tell, I guess, what this text is like. I don't know why I decided to take there's something holding a GPT-4 back. I don't know, I suspect it's the fact that I was using it on accessing the same chat on the phone. Can you give a text summary for the whole conversation from the beginning? Just stick to text. Yeah, it's a tricky business because the website version, browser version, doesn't have chat functionality, so it does have a voice output but no voice input, because the app has both. So let's yeah.
Conversation summary. 1. Initial request. User wants to create a functional Flask application to compare normal and abnormal gait side by side using a 2D model of the foot with a heat map displaying pressure changes. They emphasized using JavaScript for the front end and minimal back-end processing. 2. JavaScript library. The discussion identified D3.js as a suitable JavaScript library for visualizing the gait data. The user also expressed interest in using existing open source datasets to simulate gait data. 3. Gait data generation. Python code was provided to generate JSON files simulating normal and abnormal gait data. The initial generated data was randomized, and the user asked for more realistic data based on actual datasets. 4. Foot image integration. A background image of a foot was created and integrated into the heat map visualization. Adjustments were made to ensure data points aligned correctly with the image, but the user preferred the heat map to represent pressure without the background image. 5. Heat map adjustments. Adjustments were made to the JavaScript and CSS to ensure the heat map used a color scale from blue, low pressure, to red, high pressure, and data points were aligned to simulate a walking gait. 6. Dataset integration. The user provided a specific dataset format. The dataset includes 19 columns per line, representing time, VGRF on sensors under each foot, and total forces. 7. Data extraction and transformation. Pseudocode and Python scripts were created to extract data from the provided dataset and transform it into JSON format suitable for the heat map visualization. 8. Visualization enhancements. The conversation included refining the foot coordinates to ensure a realistic representation of the foot shape and pressure distribution during a gait cycle. Key steps and adjustments. Initial visualization setup, using D3.js to visualize gait data as a heat map. Data generation. Python code to simulate normal and abnormal gait data. Foot image. Created and integrated a background image of a foot. Heat map adjustments. Adjusted the color scale and data point alignment. Dataset integration. Provided scripts to extract and transform dataset into JSON. Final adjustments. Refined foot coordinates and pressure visualization to ensure accurate representation of gait data. This summary encapsulates the key points and steps taken throughout the conversation to develop and refine the gait visualization application.
Yeah, there was a yeah, so that was the previous chat. The previous application. I also in parallel trying to do this knowledge graph thing. It's a bit odd. Where's the... It's not picking up on... Yeah, it always gets messed up by references. Still not great. For one of the blogs it was actually better. I don't remember which one was it. I don't know if it means it's a better blog as well. Yeah, so this one, you have to get rid of the references. Where's the disclaimer? OpenAI GPT-4. Yeah. Hey, get rid of that. All right. So that went away. Yeah, should be able to just extract the text out of it. Epilepsy EEG imaging, PET, blah blah. But then it has, yeah, I don't know why it has the, still the references are there. Yeah, I got rid of that 2020. Yeah, so it's kind of manual like that. Is Benna still there? Yeah, it's still there. So it was looking at the capitalized words. Smith is there. Of course, there's a Smith in every a reference list. So it was weird that got rid of the 2020 because there was another one. Anyway, you get the, yeah, should get rid of the names, take out terminology. What's this? 2016 daily, what? Doesn't make any sense, does it? It's in the, assume it is in the text somewhere. 2018 RAM. The American Academy. Yeah, there should be, yeah, before turning anything into a knowledge graph, you have to get rid of any irrelevant names. Like it's Fisher. Yeah, Fisher. Yeah, when we hover over, we should see the whole concept. That would help, wouldn't it? One says chat is disabled. What? Okay. Chat is working okay. Ah, yeah, it's probably disabled. If you never chat, if you never commented on if you never commented on a YouTube video, then yeah, I think you need to hit, essentially need to become a creator. So to be able to chat, I think, not sure. Surely, well, I shouldn't assume anything, but surely. Um, you commented on the YouTube video before. I can bring you live on Zoom as well, if you like. We also had those feed files that we're trying to pass, so I had some trouble with that. We were trying to do it with JavaScript alone, but had trouble with the JavaScript code. I have to check that application. Where was it? The feed data. Pum, 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 pum. Hi Kumar. Yeah, the chat. I forgot about the chat in YouTube. Wouldn't work unless you placed a comment on somebody's video before. It's also not updating in my phone, so I have to. Yeah, only after refreshing the page. So I have to be in my YouTube studio thing to see messages. It's a bit annoying. Yeah. Yeah, let me know what your interests are. Currently doing this knowledge graph that we're trying to fix. This live though, you can, it gets updated as you type, which is nice, but then sometimes it's showing some rubbish. As in, if there is rubbish in the text, it's not changing the text or anything. The other thing, we were doing this feed file passing from a wearable. We had trouble with that one as well. Yeah, earlier today we were trying to do like a gate monitoring thing that also didn't work. So yeah, good luck. The bot gods are not being nice today. It was stuffing up like the food. It couldn't make a proper food coordinates. Actually, this one was actually accurate. Just that table in paper was incomplete. Yeah, we're doing. What else were we doing? Doing something else. A graph. Ah, I had the two bots. Not two bots, it was the same bot. But having a chat to one another, that did not go quite well. Yeah, because there weren't. There's no function to actually interrupt the bot while it's talking. Like not with voice, you actually have to press on the screen, which was kind of defeating the purpose. Yeah, online there's no chat function, so I have to use the phone. That's not ideal, is it? Can you give a quick summary for this conversation? Can you give an overview for this application and how it could be used in general terms as well? Yeah, because now it's giving a broader perspective on it, which is good. So it's to do this knowledge graph stuff. Yeah, I have to change the default sample. Default sample. Yeah, this one. Or should we generate a new one? Oops, let's keep forgetting.
Application Overview. This application is a web-based tool that generates knowledge graphs from text data. It extracts entities and their relationships using natural language processing, NLP, techniques and visualizes them interactively using D3.js. Key components. 1. Backend. Flask handles HTTP requests and serves the web application. Spacey performs NLP to extract entities and relationships from text data. 2. Frontend. D3.js visualizes the extracted entities and relationships in a dynamic, interactive graph. HTML, CSS, JavaScript provides the user interface and handles interactions. Core features. 1. Text input. Users can input text directly into a text area on the web page. 2. Entity extraction. The application uses Spacy to identify and extract entities, e.g. names, places, organizations from the input text. 3. Relationship mapping. It identifies relationships between entities within the text. 4. Dynamic visualization. The extracted entities and relationships are visualized as an interactive graph using D3JS. 5. Interactive graph. Users can zoom, pan, and drag nodes to explore the graph. General use cases. 1. Text analysis. Researchers and analysts can use the application to visualize relationships in large text documents, helping to identify key entities and their connections. 2. Educational tool. Educators can use the tool to teach students about NLP, data visualization, and the importance of understanding text-data relationships. 3. Content summarization. Journalists and content creators can use the application to quickly summarize and visualize the key elements and relationships within their articles. 4. Knowledge management. Organizations can use the tool for knowledge management, visualizing relationships within large data sets of text to uncover insights and make informed decisions. 5. Data integration. Businesses can integrate the tool into their workflows to analyze customer feedback, market research, and other textual data sources, providing a clear and interactive visualization of the information. Summary. This knowledge graph generator is a versatile application that helps users visualize complex relationships within text data. By combining NLP for entity extraction and D3JS for dynamic visualization, it provides a powerful tool for text analysis, education, content summarization, and more.
Yeah, so give it these two images where the connections are unnecessarily tangled up. It should really be displayed like that on a first go. Font size, dynamic font size adjustment. I thought we already did this before in word wrapping, force simulation adjustment. Modify the force simulation parameters to reduce tangling. Okay. Yeah, and I did ask it to use mainly JavaScript, not the back end. Getting these errors in Visual Studio Code. Increase the node radius for simulation. Increase the distance to 200 to reduce tangling. Increase the negative charge to -500 to spread out the nodes. Okay. Text dynamically adjusted and wrapped. Sounds good. The code is shorter. Why? Nothing. Errors. Bow. Any placeholders in this was the last code that actually working. Let's see what the GitHub Copilot says. We're changing the fit within a node append radius of the node. Okay, let's just increase the radius of the node. And the radius now is dynamically changing. Okay, the text is now larger, but obviously that's obviously not cool. Come on. Yeah, we have a new function. Be inside the visualized graph, isn't it? Don't see any text whatsoever. No, I'm pretty sure it's just not the color. X node within the node. Okay, feels like I'm gonna be going in circles again. Yeah, it's not doing that. Oops. That's not great, is it? Oops. Not quite sure how Copilot works in terms of like hierarchy of things. The down typing interval is fine. Yeah, the radius so should all the nodes be the same. Yeah, it's just a bit of frustration move. I know it's not doing great. Test it with different text. Right. Well, it was better before. Get rid of all these references. Yeah, just a total mess, isn't it? Just font size dynamically sounds good. By the way, this session is meant to be interactive if, especially if you have checked yeah, live is still going. That's nice. Didn't expect. I thought it will die out. What else we've got? Yeah, don't forget to turn your ad blocker off so you'll be supporting the project when visiting the page. And let me know what you think.
To improve the visualization and ensure that the text fits well within the nodes and the layout is clear, consider the following adjustments. 1. Adjust font size dynamically. Ensure the font size adjusts dynamically based on the text length to fit within the node. 2. Improve force simulation. Adjust the force simulation parameters to better spread out the nodes and avoid overlapping. 3. Ensure consistent text wrapping. Make sure the text wrapping function correctly splits text into multiple lines if it exceeds the node width. Updated code. Here is the updated code with these improvements. JavaScript document.add event listener DOM content loaded equals const text input equals document get element by ID text input input.add event listener key up handle typing. Initialize the graph on page load if text input value done typing. Let typing timer const done typing interval equals 1000. Time in MS 1 second function handle typing clear timeout typing timer. If this dot value typing timer equals set timeout done typing interval. Function done typing const text input document.
Okay. If the code is adjusting correctly, I mean, if the text is dynamically changing size, then we don't have to truncate, do we? This one. Yeah, I wonder if I do not prompt, what will it make of it? Maybe not. Just would be able to see if it's any better or not. Is it any better? Doesn't look like it did much. select text, can search for text, node. Yeah, the text needs to be cleaner. Yeah, like they do in the news. Studies have shown. Forget the reference. Well, just messing up a knowledge graph. EG meg electrode. Using text only, can you describe how the graph, knowledge graph generator can be improved? There's a couple obvious things. First of all, we need to explain how concepts are being extracted from the text. Is it only taking capitalized words at the moment? Also, if we are dynamically adjusting the text size, do we still need to truncate certain elements? Also, do we make sure that there is not more than one or two words in each node? Let's say 2 nodes, absolute maximum. Yeah, just say bye bye for now, just to be safe. And yeah, we'll continue next time. If you did check any of the tools on bindingchaos.com, please go do check them. Someone told me on LinkedIn that they got hacked when checking the website. Well, okay, that's impossible. I mean, definitely not from my end. The website, if you noticed, it's not asking for any personal information. Actually, when you use any of those tools, the data is not actually being sent to the server, so it's not grabbing your face. I mean, yeah, could potentially, if was malicious. I mean, yeah, just if you don't trust the website, don't visit. Yeah, it could grab your face in theory and use it to unlock your phone or something if you have a Face ID. But again, you could also check what's running on the website. You go F12, yeah, blocking ads, and you can see what each one of those tools actually doing throughout your browser, because You have all the source code in it that you can see it, you can check it, see by yourself that there's nothing malicious in it. And you can also see what it's sending back and forth. So when you use one of those tools, when you hit allow, you could actually see that the data is not being sent to the server, it stays on your local machine. But again, if you don't trust the website, don't visit it. Yeah, I'm already using the camera for the stream, so I can't do that, but over here you'll be able to see every time you change something, because there's no network communication. This is all happening locally. So yeah, I should have my second camera webcam stopped working. So yeah, visit the website if you want to support the project, so I can get better cameras and stuff, and potentially produce better content. Let's see what's happening. Ooh, in live. Why? I'm actually not pressing the keyboard. That's really weird. I don't know. Yeah, I have to optimize this one for mobile phone as well.
Improvements for the knowledge graph generator. 1. Concept extraction, current method. Explain how concepts are currently being extracted from the text. If it's only taking capitalized words, this might miss important concepts. Enhanced extraction. Use an NLP library like Spacey to perform named entity recognition and part of speech tagging to extract meaningful concepts and relationships. This ensures more accurate and comprehensive concept extraction. 2. Dynamic text size adjustment. Current method. The text size is dynamically adjusted based on the length of the text. Improvement. Instead of truncating text, dynamically adjust the font size to fit the text within the node. Ensure the font size is readable while fitting within the node's dimensions. 3. Text wrapping and node content. Current method, text might be truncated to fit within the nodes, and there may be more than 1 or 2 words per node. Improvement. Word limitation. Ensure that each node contains no more than 2 words. This keeps the nodes concise and easily readable. Text wrapping. Properly wrap text within the node if it exceeds the node's width. Split the text into multiple lines if necessary, but still limit it to 2 words per line. 4. Force simulation and layout. Current method. Nodes may overlap or be too close together, making the graph hard to read. Improvement. Adjust the force simulation parameters to spread out the nodes more effectively. Increase the repulsion force and link distance to reduce node overlap and ensure a clearer layout. 5. Interactivity and user experience. Current method. Users can zoom, pan, and drag nodes, but further improvements can be made. Improvement. Tooltips. Add tooltips that appear on hover, providing more context about each node and its relationships. Highlighting. Highlight nodes and connections on hover to improve visibility and focus on specific parts of the graph. Search functionality. Implement a search feature that allows users to find specific concepts within the graph. 6. Graph initialization and updates. Current method. The graph is updated based on user input, but the process might be optimized. Improvement. Smooth transitions. Ensure smooth transitions and animations when the graph updates to enhance user experience. Efficient updates. Optimize the update process to handle large data sets efficiently, ensuring quick response times. By addressing these areas, the knowledge graph generator can be made more accurate, user-friendly, and visually appealing, providing a better tool for exploring and understanding complex text data.